In the vast silence of space, even the faintest flicker can change everything we think we know. 2 nights ago, an event occurred that sent shockwaves through every major observatory on Earth. The interstellar object known as 3I Atlas, a mysterious traveler from beyond our solar system, suddenly erupted in brightness, not gradually, but explosively. In just 6 minutes, its luminosity surged fourfold. The flash was so brief and so precise that telescopes across continents recorded it at the exact same moment. Mars orbiters expended fuel to reorient their sensors. The Deep Space Network suspended ongoing missions, and the International Astronomical Union called its first emergency session in years. Scientists who once shared data freely went silent. Whatever was happening out there wasn't just another cometary outburst. It was something entirely different, something no one could yet explain. It began, as revolutions often do, quietly. In a small German town, amateur astronomer Maria Schultz noticed something strange in her nightly observations. While studying 3I Atlas through her 12-inch telescope, her software flagged an anomaly. A sudden leap in brightness, 1.4 magnitudes higher than before, sustained for 6 minutes. At first, she assumed it was a glitch, but when she checked her calibration stars, her optics, even the atmosphere itself, everything was perfect. Within 30 minutes, observers in New Zealand, Arizona, and Brazil began reporting the same results. The light curve was impossible, neither sinusoidal nor periodic. Just a flat line that suddenly spiked like a heartbeat, then held steady. No comet, asteroid, or fragment had ever behaved like this. For comparison, the legendary outburst of Comet 17P Holmes in 2007 took nearly 2 full days to brighten by the same magnitude. What Schultz saw happened in less than 1% of that time. By midnight, the hashtag Atlas Anomaly was trending worldwide. Within hours, astronomers everywhere were asking the same question: what could cause such a clean, instantaneous burst of light? A digital chain reaction followed. Forums, research servers, and citizen science groups like Skywatch Collective flooded with identical screenshots, exposure logs, and light curves matching down to the minute. The anomaly wasn't a hoax, it wasn't equipment failure, it was real. By dawn in Europe, professional observatories were on alert. Pan-STARRS and the Atlas survey confirmed the spike. Joined by robotic telescopes in Chile and Japan, data streamed into a shared public repository, a digital reflection of human curiosity. Then, silence. The professionals took over. The Deep Space Network halted Mars telemetry, rerouting its massive 70-meter dishes toward the coordinates of 3I Atlas. Engineers voted unanimously to override routine scheduling, sacrificing data from Perseverance and Voyager to capture radar reflections from a single interstellar visitor. It was an unprecedented decision. 22 hours of lost mission time, a measure reserved only for life-threatening asteroid flybys. Yet this wasn't an impact threat. It was a light anomaly. And still, the world's most powerful antennas turned their gaze toward one point in the sky. By the following morning, the Very Large Telescope in Chile, Gemini North in Hawaii, and even China's Fast Radio Telescope had all abandoned their planned targets. The IAU voted 8-2 in favor of a planetary-scale observation campaign, a rare act of unity in a field often divided by funding and competition. For 48 hours, humanity's finest instruments watched a single object, then nothing. The same astronomers who had been posting hourly updates vanished from public view. Research channels went dark, no new data appeared on preprint servers. Analysts tracking online activity noticed a sharp 70% drop in communication from verified astronomers who had been discussing the event. Something had changed behind closed doors. The few automated logs that leaked painted an unsettling picture. Radar readings showing non-gravitational acceleration 4 times stronger than expected. Infrared emissions plateauing 30 Kelvin above normal, and faint bursts of gamma radiation coming from 3I Atlas itself. None of it made sense, and yet it was real. Within 2 days, the event had evolved from anomaly to full-scale mystery. Mars orbiters confirmed the same infrared excess from millions of kilometers away. Ground telescopes recorded identical accelerations. Deep space antennas detected faint, rhythmic echoes pulsing at precise intervals. But the most haunting detail wasn't found in the data. It was in the silence. Astronomers who had spent their lives studying comets now refused interviews. Entire observatories entered lockdown under the banner of data verification. An internal IAU report, leaked by an anonymous source, described the situation as a synchronized global anomaly requiring immediate containment. No further explanation, no press release. Only one directive: maintain continuous observation until further notice. For the first time in modern history, every eye on Earth was fixed on one object from another star, an object that, in a matter of hours, had forced humanity to reconsider what it means for something to be natural. Then came the discovery that changed everything. Using differential imaging from the James Webb Space Telescope, researchers began to notice something extraordinary: a secondary object, smaller, colder, and perfectly aligned with 3I Atlas's trajectory. At first, it was dismissed as a fragment or a drifting dust cloud, but over successive scans, the object maintained a fixed distance of exactly 120 kilometers, moving in perfect synchronization with the primary body. It wasn't drifting, it was orbiting. The findings sent immediate shockwaves through the IAU's emergency channel. A natural object with a companion this close should have been gravitationally unstable, yet this pair moved with mathematical precision, as if bound by invisible control. Even stranger was its spectral signature. The secondary body reflected almost no sunlight, but it emitted faint microwave radiation consistent with active heat regulation. In simple terms, it appeared to be controlling its own temperature. By this point, most astronomers had stopped referring to it as a comet. Quietly, the official designation changed from 3I Atlas C/2025 R2 to 3I Atlas Complex. The new name wasn't arbitrary. It was a subtle acknowledgement that this was no ordinary body of rock and ice. It was something more. Everything reached a breaking point when 3I Atlas crossed a position known as nodal alignment, the moment when its orbital plane intersected Earth's. At that instant, every major observatory, telescope, and radio dish on the planet registered a sudden surge in intensity. The pulse frequency increased, the secondary companion brightened, and the region surrounding both objects filled with a faint, expanding halo, visible even through amateur telescopes. It wasn't reflected sunlight, it was internal luminescence, energy radiating outward from within the structure itself. Data from the James Webb Space Telescope revealed diffraction spikes consistent with geometric edges, not random debris. Whatever 3I Atlas was, it seemed to be unfolding. Spectrographic readings showed a sharp temperature drop, nearly 60 Kelvin, suggesting that energy was being redirected inward. Then something happened that no one could have predicted. For the first time, 3I Atlas emitted a directed radio beam, focused, narrow, and aimed precisely at Earth's ecliptic coordinates. The signal lasted only 12 seconds, but it wasn't noise, it carried structure, harmonic symmetry, and patterned intervals far beyond anything found in natural radio bursts. Then, just as suddenly as it began, it stopped. The light dimmed, the pulse vanished. 3I Atlas fell silent once again, and one haunting question echoed across observatories worldwide. Who or what was listening on the other side? For days, the world waited for an explanation. That brief 12-second transmission had already become the most analyzed signal in the history of astronomy. Then quietly, one observatory broke the silence. At the Square Kilometre Array in Australia, researchers reconstructed the full waveform using the world's most advanced radio network. They expected to find random background noise. Instead, what they uncovered stunned them. The signal wasn't random. It contained a harmonic framework built around the same 247-second pulse that had puzzled astronomers for months. Embedded within the pattern were frequency ratios, identical to hydrogen's spectral lines, the universal constant of communication. Hydrogen, the most abundant element in the universe. is the cosmic alphabet. The one signal every scientifically capable civilization would recognize. Whoever or whatever generated that beam had chosen the frequency of understanding itself. But the true revelation came when the waveform was rendered visually. Converted into a spectrogram, it revealed a repeating geometric structure, 6 perfect hexagons spiraling outward around a single point of light. It was a mirror image of James Webb's final images of the 3I Atlas complex. The primary and secondary objects locked together in a precise formation. The transmission wasn't just a signal, it was a blueprint. When scientists rendered it in 3 dimensions, the geometry corresponded almost perfectly to the orbital architecture of our own solar system. Each hexagon represented a resonance, a harmonic alignment between planets. But there was one crucial difference. At the center wasn't the sun. It was empty, a void, positioned exactly where 3I Atlas now drifted. The scientific community split in 2. Some argued it was coincidence, a cosmic pattern our minds were too eager to interpret. Others, including Harvard's A.V. Loeb, described it differently. He called it a synchronization event. According to Loeb's paper, the signal's purpose was never to communicate in the way we understand communication. It was to tune something, a calibration sequence between the object and the solar system itself, as though 3I Atlas had locked onto our gravitational rhythm and adjusted accordingly. Loeb compared it to a musician tuning an instrument before the performance begins. If that's true, then the 12-second transmission wasn't the message. It was the test tone before the real transmission. Then came another revelation. As the data spread across research institutions, analysts noticed an unsettling pattern. Earth's own magnetic field had fluctuated precisely 12 seconds after the beam ceased. The same pulse, the same interval, echoing through our atmosphere. It briefly altered the ionospheric resonance, shifting the Schumann frequency by just 0.02 hertz. To most, that number meant nothing. But to those studying the event, it was proof that the transmission had interacted directly with Earth for a fleeting moment. 3I Atlas had reached across 300 million kilometers of empty space and touched the planet. The official responses were predictable. Talk of instrumental errors, solar interference, and data misclassification. But behind closed doors, a very different picture emerged. Within days, the International Asteroid Warning Network quietly assembled a new division, Project Helios. Its findings were never made public, but according to internal correspondence later leaked to scientific forums, the task force reached one extraordinary conclusion. The directed beam wasn't a random transmission, it was a response. When amateur telescopes first detected the brightness surge weeks earlier, Earth had unknowingly emitted its own faint electromagnetic signature, a chaotic flare of signals from thousands of synchronized devices, telescopes, satellites, radar arrays, and communication towers. That noise had bounced off 3I Atlas, and the object had answered. The sudden brightening wasn't spontaneous. It was reflection, illumination sent back toward us. And now, silence. No pulses, no gamma spikes, no measurable acceleration. The interstellar traveler drifts quietly beyond Mars, silent, watchful, and unreadable. The data remains classified. The headlines have faded. The world, for the most part, has moved on. But among the small circle of astronomers who first detected the 247-second rhythm, one question remains. What happens when that frequency returns? What if the next signal isn't made of light, but something else? Because maybe 3I Atlas didn't come to visit. Maybe it came to synchronize. So if this story made you question what's truly happening out there, don't look away. Subscribe to the channel where Discovery never sleeps and turn on notifications. Because when the signal returns, and it will return, you'll want to be here to hear it.